All right, let's start chapter 3. Since I have all of your attention, hopefully, just need to emphasize the fact that you need to take good notes and write down the definitions and actually read them as you're writing them down. I've compiled a list of all the definitions, postulates, and theorems we've done in chapter 1 and 2 so far, and I have like 4 pages of just a list. And you can't forget them, okay? We're still using the stuff from chapter 1, and we're still using the stuff from chapter 2. So get everything together so that you can just flip back and forth on those notes or on that note card and get all the stuff that you're needed. And we'll move on. So our definitions right now, I have parallel lines. Two lines are parallel lines if they do not intersect and are coplanar. So here I have lines M and N. Okay, they do not intersect and they are coplanar. They're both on plane T. Right here you have plane T. So line M and N do not intersect and they are on plane T. Very, very important is this right here. Okay, these two little red arrows indicate that these two lines are parallel. This little red arrow and this little red arrow mean that they are parallel. Okay, they're like tick marks. I could actually put 2 red arrows. It would just be like 2 tick marks. Okay, if both lines have the same number of red arrows, I'm sorry, those look like terrible arrows. If both lines have the same number of arrows, then they are indicated as parallel. Next, skew lines. 2 lines are skew lines if they do not intersect and are not coplanar. Okay? I have line K and line N. They intersect right here, though, so they are not skew. But I have line K and line M. They do not intersect and they are not coplanar. So line K and M are skew. Parallel planes. 2 planes, not plans. 2 planes that do not intersect are parallel planes. I have plane U and plane T that do not intersect and are parallel planes. When 2 planes intersect, I can actually write it like this. Oops. U is parallel to T. Okay? There's no way for me to signify on the drawing that they are parallel like I can with the lines. But if I have parallel lines, I can say line M is parallel to line N. And that's it. Okay. Oh, the last thing I want to point out in here is line K and N are intersecting lines, but I didn't write down the point. Okay, they intersect at that point. Next. All right, let's try an example. Think of each segment in the figure as part of a line. Which lines or planes in the figure appear to fit the description? First, we want to look for lines parallel to line CD. Okay, which is right here, containing point A. Okay, parallel to CD containing point A. I see line AB is parallel to line CD. I also see line EF is parallel and line HG is parallel, but they do not contain point A. Okay, so there's just that one. AB contains point A. Lines skew to CD and containing point A. So remember, skew means they are not on the same plane and they do not intersect. So I see line AH is skew to line CD. And it looks like line AG is also skew to line CD. Okay, I have this one right here, and this one right here. Okay, there are other lines that are skew, like that one would be skew, but it's not, doesn't contain point A. This one back here is skew, but it doesn't contain point A. Okay, let's erase all this stuff. But those two lines do appear to be skew and contain point A. Lines perpendicular to CD and containing point A. So here I have this line right here, which is perpendicular. This line is perpendicular, but that second line does not contain point A. So I just have line AD is perpendicular to CD and contains point A. Planes parallel to plane EFG and containing point A. Plane EFG is down here. I need a plane parallel to EFG and containing point A. Looks like this plane up here. So I'm going to say plane ABC. And you can name that with any 3 points up there. Okay? Any 3 points you want. Alright, parallel and perpendicular lines. Two lines in the same plane are either parallel or intersect in a point. Okay? Through a point, not on a line, there are infinitely many lines. Exactly one of these lines is parallel to the given line, and exactly one of them is perpendicular to the given line. Okay, let's look at this drawing. I have line L and point P. Okay, line L and point P. The first one says that through point P, I have exactly one line parallel to line L. So through point P, I have exactly one line parallel to line L. That's the first point. And through point P, I have exactly one line perpendicular to line L. Only one. Through point P, I have only one line parallel to line L, and through point P, I have only one line perpendicular to line L. Okay, this line J just signifies that I have infinitely many lines through point P. I can draw as many as I want. Infinitely many lines. So I can draw lots of lines, that was not through point P, lots of lines through point P that are not perpendicular or parallel to line L. Okay, but I have exactly one line perpendicular and one line parallel. Postulate 13, the parallel postulate. If there is a line and a point not on that line, so if there is a line and a point not on that line, then there's exactly one line through the point that's parallel to the given line. There's exactly one line through P parallel to L. Postulate 14. If there is a line and a point not on the line, then there's exactly one line through the point perpendicular to the given line. Okay, so now we learn postulate 13 and 14. Let's try it. Photography. The given line markings show how the roads are related to one another. Name a pair of parallel lines. Okay, and if you remember, we change to red. Okay, I have a double arrow here and here. So I have a pair of parallel lines. And if I can read that correctly, it looks like line M is parallel to line, goodness, I think that's line E. Let's erase that. Okay, and try this again. It's hard to read those. I opened up the book and I'm looking there because I have points and lines, and so I'm looking for a pair of parallel lines, which what I circled is correct. Okay, there are my double arrows, so I want to say that those lines are parallel, but they've not really made it clear. Okay, so it looks like I have line DM is parallel to line EF. Cool. Name a pair of perpendicular lines. So I'm looking for that little right angle, which you really can't see on this, but it's right there. So I can say that line DM is perpendicular to line MB. I'll say BM, only because it's alphabetical order. Okay, so I have a pair of perpendicular lines. Now it's asking, is FE perpendicular to AC? FE is right here, perpendicular to AC. No. Okay, your reasoning would be, I already have FE perpendicular to DM, so FE can't be, parallel. Let's try that again. I already have these two pairs that are parallel, okay? So FE is parallel to DM. If you go back and read the parallel postulate, there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. Okay, so if we look, FE, I'm going to make that in green, FE parallel to AC, we've already said that FE is parallel to DM, there's M, so we already used point M for this one, and that postulate says one pair of parallel lines, let's use a symbol here, through one point. Okay, you can only have two lines that are parallel through this point. So these two are parallel through point M, so this one can't be parallel through point M also. Okay. One more time. These lines are parallel through point M, so this line cannot be parallel to this one through the same point. You try. Look at the diagram in example 1. Name the lines through point H that appear to be skew to CD. Okay, push pause. There you go. Let's try the next one. You try again, push pause. In example 2, can you use the perpendicular postulate to show that AC is not perpendicular to BF? I have AC and BF. Okay, why or why not? They are not perpendicular because DM is perpendicular to BF through point M. Okay, and that postulate says that two lines can't be perpendicular to the same line through the same point. Or it actually says that if there is a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. Okay, let's erase that. All right, you guys need to write this down. These are all concepts that we are going to use a lot through this chapter, and we need to remember them. Okay? Angles formed by transversals. Okay, first we have a transversal is a line that intersects two or more coplanar lines at different points. So I have two lines that are coplanar and a line that cuts it. Okay, so this is a transversal, the T. These are all the transversals. Intersects two or more coplanar lines at different points. Okay, first I have corresponding angles. Okay, you notice they're on the same side of the transversal and on sort of the same sides of the double lines. So it's always like on top and on top. but they can also be on bottom and on bottom. Okay, if they were where the red dots were instead of where the numbers are, they would be fine. Those are corresponding angles. Okay, the next one is alternate interior. Okay, it's on the interior of these two lines. Okay, so interior, and it's on alternate sides. So alternate sides, interior. Alternate sides of the transversal, interior of the other two lines. Alternate exterior, if you think, they're on the exterior side of the lines, but alternating sides of the transversal. And then we have consecutive interior angles. Consecutive, I always think like it's consecutively. It goes one then the other. If I were to travel, I hit one then the other. They are consecutive. Two angles are consecutive interior angles if they lie between the two lines and on the same side of the transversal. Review again. Two angles are corresponding if they have corresponding positions. So it's, to the right of the transversal and above, to the right and above, or to the right and below, like that one, and to the right and below. Or you could even put one over here. You can put to the left and above, and to the left and above, or to the left and below, and to the left and below. Those are all considered corresponding angles. Just like these would be alternate interior to each other, or these would be alternate exterior, or these would be consecutive, okay? Another name for consecutive interior is same side interior. We're not going to use that, okay? We're always going to use the consecutive interior. Okay, identify all pairs of angles of the given type. Right, I have corresponding, alternate interior, alternate exterior, etc. That didn't work. I was hoping that those would disappear. Oh, it does. All right, so for A, I have corresponding. So let's try this. Corresponding, remember, I have two lines in the transversal. So this is the transversal. Corresponding means that they're on the same side, same position. Okay? Or, let's change colors. Same side, same position. I don't think I have this many colors. Same side, same position. Pick a new color. Pink's happy. Same side, same position. Okay, let's see if that works. Check our answer. Yep, blue is 1 and 5. Okay, 2 and 6 was red. 3 and 7 was green. And 4 and 8 was pink. Okay, those are corresponding. All right, let's see if we can erase these. Okay, let's try the next one. Alternate interior. All right. So alternate interior means that they are in the inside and opposite. Inside and opposite. Those are pairs of alternate interior. Okay, 2 and 7 were in red. Oh, so sorry about that. 2 and 7 were in red, and that is blue. Let's get rid of that. 4 and 5 were in blue. All right. Okay, let's try the next one. Alternate exterior. Okay, so the exterior and opposite sides. Exterior and opposite sides. Awesome. Okay, 3 and 6 were in red, and 1 and 8 were in blue. Try the next one, consecutive interior. So consecutive interior, I've always thought consecutive things go like boom, boom, 1, 2, just like you are traveling and you hit them one at a time. Let's erase that. That always helped me. I would always get corresponding and consecutive confused, but that's how I remembered it. So consecutive, they're on the same side, and consecutive. Let's look at our answers. Cool. 2 and 5 were in red, and 4 and 7 were in blue. Awesome. Classify the numbered angles. You try. Push pause. There we go. Classify the pair of numbered angles. So I have the transversal. Push pause. Alternate exterior angles. Classify the pair. Push pause. Alternate interior. We'll go ahead and spell that one out. Alternate interior angles. Alright, I'm going to fill in the answers for the daily homework quiz and we'll go over it tomorrow in class. There you go, one more page. Okay, I'm going to write in the answers. Push pause. There we go. Good job. I'll see you guys in the morning.